Hey folks, welcome to another session of Fast Trax Live. My name is Paul Abernathy. Today we're going to look at some practice questions that will help you understand the National Electrical Code just a little bit better, whether you're trying to learn it to enhance your knowledge of the code, or maybe you're preparing for an electrical exam. Either way, I'm going to help you learn the National Electrical Code. Now, if you are studying for an exam or you want to take your game to the next level, then I encourage you, right there, visit this website, because we specialize in teaching you the National Electrical Code. You really need to learn it. Look, exams can be tough. Understanding the NEC when you're in the field can be even tougher in sometimes. So this is your website to go to, but let's look at some exam prep questions and let's see if we can understand how to dissect them a little bit. All right, here's the first question we're going to look at. Now this question says, an article number in blank following a definition indicates that the definition only applies to that article. So what does that really mean? So one of the things that I tell people all the time is that we have definitions that are in Article 100. And if you're in the 2023 edition of the NEC, all of the definitions have been moved to Article 100. There's so many definitions there, but some of them have these specific guidance to tell you that this definition only applies to this specific article, not to the entire NEC, just to this one specific article. And so you got to ask yourself the question. If we go look at the question, which is it? Is it bold text? Is it brackets? It's parentheses, or is it italics? Let's go look at it. So here you go. You have all these options over here that you can choose from. Key is an article number that's followed by one of these means that that article and that definition are tied together. Okay, so what do we want to do? Well, let's go look and see what the National Electrical Code says to answer this question. Right? Yeah, you can answer this question with the NEC. So let's go to the lesson. All right, so we're over here in the NEC. Let's go to Chapter 1, Definitions. And boy, what do we see right up here in the middle? In fact, it's even been added for the 2023 edition. So that's important to know which edition you're in. Okay, so here, this is very specific to 2023. And what does it say? An article number in parentheses following the definition indicates that the definition only applies to that article. Well, that's real important, folks, to remember that, especially if you're studying for the 2023 NEC, things like that, is that you do want to understand that you may see a definition that you think applies broadly, but if it's followed with a code reference and article with parentheses, that means that definition only applies to that specific article. Okay, so we're going to choose parentheses. There you go. And what's the reference? NEC reference Article 100, as you just saw. Again, if you're in the 2023 NEC, that was a change. So always be aware of that, whatever cycle you're in. Let's go another one. Next one is blank is acceptable to the AHJ. What is it? Listed, approved, tested, or authorized? All right. Well, this is important. Why? Because we need to understand that when we see the term acceptable to the AHJ, authority having jurisdiction, what does that mean? Okay, well, listed has to do with the product standard. Approved, it's already saying approved is acceptable to the AHJ. Okay, tested, well, the AHJ is not going to do any testing. And then authorized. Okay, which do you think it is? Well, let's go look at the NEC and see what it says. All right, let me see if I can get us here. All right, we're in the NEC. All right, let's see what we got to do. So let's see here. We're dealing with Article 100. All right. Okay, so now we're going to be looking at definitions. Okay, so let's see here. Go down definitions and let's see what it says for approved. Approved is acceptable to the authority having jurisdiction. Okay. So obviously listed, tested, and authorized are not going to be. Now, since we're looking at definitions, we can go down and look at these other ones really quickly and see, well, what does it say about listed? Well, I'll scroll down and see if it says if it's listed. We'll look at listed. I'll click on it. There we go. As you see, listed has to do with equipment, materials, and things like that. So it's really not the AHJ deal. So obviously approved. Now, let's see here. If you look real quickly and you can look and see, well, is there anything in there about authorized? All right. And it doesn't take you long to look and see that there is nothing about authorized. However, there is a definition for AHJ, right? And again, you get to see what the definition of AHJ might be. An individual, might be a building official. It could be an application where you have like a military site and they have to assign somebody as the AHJ. If they're not, there's no government entity like an inspection group that comes in, then they have to assign an AHJ, all those type of things. So authority having jurisdiction, right? But for us, the good news is we know that is approved. And let's see what our reference is. There it is. Reference in Article 100, Part 1. That's all the definitions. And when you see something like this kind of question, it just sticks out to you as a definition type of question, right? It's just kind of, that's what it looks like. Let's do another one. All right. It says when performing branch circuit load calculations, the outlets for heavy-duty lamp holders shall be calculated by a minimum of blank volt amperes. So what do you think? You're saying, well, what are we doing? How do we dissect this question? You know, I talk a lot about dissection. And one of the things that I'm looking at this right away, and it's telling me is what? It's to perform a branch circuit load calculation. That should start sending, when you see it say something about a branch circuit load calculation, that immediately thinks of, well, I'm going to be thinking of Article 220. That's calculations. Now, we're not thinking of Part 3 because that is service and feeder calcs. We're not thinking of Part 4 in 220. That's optional. We're thinking Part 2 branch circuit applications, right? So that's where we're going to go. So let's grab our code and let's go look. So here we are in the code, and I'm going to take us down to 220. And we'll go to 220. And we're going to go down to, well, let's just start at the scope real quick. So here's the scope, kind of gives you the structure, lets you know, again, Part 2 provides calculated methods for branch circuit loads. So you immediately know that, right? So you know you're going to go down to Part 2. It doesn't take you long to get to Part 2. And this is the 2023 edition of the NEC that we're looking at here. But it's still the same in the 2020 or 2017. You're still dealing in Part 2 when it comes to branch circuit load calculations. All right, so one of the things is, remember, I always talk about dissection. It's not much to know that when we're looking at this question, it was talking about what? Heavy-duty lamp holders. Once you identify heavy-duty lamp holders and you know that the answer is going to be either 100, 400, 600, or 800, and it's an answer in volt amperes. That's what we talk about when we say dissecting a question. Using the answers as well as the question and keywords in order to help you out when you're preparing for the exam. You're not going to know everything in the code, okay? But if you know how to take a question and dissect it and use the important parts of it, then you can answer this question. And again, it's going to take some knowledge. You can't get a course that's going to give you everything. Okay? It's just no way to do that. But if we teach you how to find things, keep you going in and out of the course material to the NEC, back to by following those chevrons, a lot of this stuff will start to click and you'll realize how to look at a question and dissect it. And it's not just for exams. This actually helps you in the field as well. So in this case, we're looking for what we call bold scanning, and we're looking for something to do with heavy-duty lamp holders, that type of scenario. So here we're at the loads. We're coming through 14. Okay, we're looking at, boom, right there. Heavy-duty lamp holders. Okay, it says, immediately I see 600. You're on an exam. Time is of the essence, and that is one of your answers. So what are we going to do? Well, we know that we're going to stop right there. That's lamp holder. Again, we know it's under 220, so we're definitely going to go answer the question. So we go over here. we're going to click on boom. There's our answer, and there's our code reference right there. Oh, by the way, this database is in your course, whether you purchase our Black in Plus or you purchase the Basic or the Enhanced. You'll get access to these type of questions. All right, let's go on to another one. Y'all are doing great. Next one says blank is constructed so that dust will not enter the enclosing case under specific test conditions. All right, so you're probably thinking, all right, well, this is critical for those that are in the 2023 edition of the NEC because all of these definitions for things like combustible dust, all of that, what you see here, dust tight, dust proof, the NEMA, all of this now is still in a definition, but it's in Article 100 now, Part 3. Whereas before it was scattered throughout Article 500, 501, 502, 503. But now definitions, even for those hazardous classified locations, have all been brought into Article 100. And now Part 3 has to deal with that. So let's go look at it in our code book and see what we got. So let's go on and get back to the NEC. And let's go on and get back to Article 100. And we'll go on down and we'll get into Part 3. And let's see here. Give me a second while I pull it up for us. Bear with me here as I'll go through this here. I'll just get us there. Okay. All right, so we're kind of going down through the different definitions and everything. And again, depending on which code cycle you're in, you'll go down through the different ones. All right, so I'm going to show you something different. So the Part 3 is specific to other code references, other codes to the 2020. And now you see it's going to be a little different here as you see me scrolling through. And I want to show you until I get to the end here. Let's keep going really quickly. Did you notice that it's all just Article 100 now? Whereas in the 2020 edition, and I'm going to show you that real quick so that we can go back. I love doing this. Here's the 2020 edition, Chapter 1, Article 100. And you'll see that this is 2020 I'm showing you. And you'll go down and you'll see that it's broken into parts. Hold on, let me get down there. A lot of stuff to scroll on link, folks. So let's get down here. All right, boom, I want to get to it really quick. All right, right here. So in the 2020 edition, all of these definitions were put here in Part 3, right? So that's why we say if you're in the 2020, your reference is going to be Article 100, Part 3. If you're in the 2023 edition, and I'll take you back to the 2023 edition, and we will go into 100. I want to show you now that the way this works is that everything now is in here. And the reason I want to show you this is because what we're going to be looking for is definition. And in this definition, I'll scroll down and show you. Okay, see right here? See the term dust tight? So this is now not under Part 3. In the 2023 edition, it's just everywhere. Okay, the definitions are just lumped together rather than go to Part 3. All right, so what does it say? Enclosures constructed so that dust will not enter under specific test conditions. Now, when we look back at the question, okay, and I'll go back to the question. We look back at the question. The question either was dust proof, dust tight. NEMA 3R typically is for water. NEMA 1, if you know NEMA 1, you know that's for interior enclosures, right? So the only ones that can make sense was dust tight and dust proof, right? So if you're on an exam and you're going back to the code reference over here, you'll look and see, well, we've got dust tight. Right now, is there anything in there for dust proof? So let's look and see. So I see dust ignition proof, but I don't see a definition for dust proof. So that would not take you but a second. And you're going to end up coming back and realizing that dust tight is your answer. Okay. So that's just kind of a way to work you around all the possibilities. And yeah, you might know this right off the bat. But if you don't, then it's going to help you to be able to isolate out. And again, look at what the question's talking about dust. It's nothing to do with 3R, nothing to do with NEMA 1. However, a 3R may be something that can utilize, because what does it say right here? Informational notes remind you of certain things to go look at. Okay, different informational notes, talks about NEMA 250 and all that kind of stuff. So you have it also tells you the different enclosures down here. Notice what's missing? I don't see a 3R anywhere. I see a 3, 3X, 3S, 3SX, 4. Okay. So you'll get to know all these things. And that way, immediately, I wasn't going to go to 3R because y'all are familiar with it being like rainy, wet, or NEMA 1 is interior enclosure. So that limited you to a 50-50 option. And when you went to look at the definition, and this looks like a definition, then you will find out quickly that dust proof is not there. So it's got to be dust tight. And there you go. Now, this is part 3. That is specifically to the 2020. It's just Article 100 definitions for the 2023. Hopefully that helped you out. I know we're a little, oops, let me go back to the lesson here. I was a little long-winded on that one, so hopefully helped you. All right, next one, it says a device that establishes an electrical connection to the earth is a what? Grounding conductor, grounding electrode, grounding solid, or ground. Now think about this question. You can eliminate a lot of this by dissecting it and saying, okay, we're talking about a device. Now don't get confused with like switches and receptacles, which are devices, but we're talking about something that's actually going to establish the connection to earth, not from a panel to a device that connects with the earth. Okay. So this one's like here, we're thinking of what is the device? Well, this one should be a no-brainer for you. Again, looks very much like a definition, doesn't it? Okay. So when you go look at the definitions, you're not going to see one for ground. You're not going to see one for grounding solid. You're going to see grounding electrode. And that's the device that is connected into the earth that you're going to connect to. So what is the component that literally is going to connect the system to the earth? It's that device. And that is your grounding electrode, right? Again, that's going to be Article 100. That's going to be where you establish that information. All right. Next one. In judging equipment, considerations such as blanks shall be evaluated. Electrical insulation, arcing effects, size and weight, or A and B. All right. Well, when you think about this, we have to say, well, obviously the electrical insulation has got to take place, whether it's a conductor's insulation rating. And then, of course, you might think, well, what about the arcing effects? What's its arc rating? Does it have an arc flash rating? It has what's it rated for? Available fault current? All of those types of considerations. Size and weight, that's really ambiguous. We don't know what it means. And then the only other option is A or B. So if you believe that arcing issues like arc fault 110.9, 110.10, available fault current, all this contribute to arcing effects, obviously that's relevant. And then, of course, the insulation on the various pieces of equipment that is insulated, that's got to play an effect, right? But what else? This question kind of looks like what? It's asking you about working requirements, the actual installation type of requirements. And so what would that be? Well, would be like an Article 110 type of thing, right? And since this looks like early on in it, where it's talking about some clarity to these type of things that are considerations when you're evaluating equipment, then it very much looks like a 110 aspect of it, okay? So let's go into the code and let's go look. And let's go to Article 110 and see what that's entailed. So 110 is entitled general requirements for electrical installations, right? Pretty straightforward. Now, when you start looking down it, you're going to see, okay, examination, right? Evaluation, you're looking at this and going, well, the question said in judging equipment. So it is examination, identification, installation, use, listing, and all that type of thing. All right, so let's think about this here and say, okay, what is number 4 of this evaluation, this examination of equipment? Okay, and here it says examination, and it says in judging equipment. Doesn't that look like what our question was? And if you look down, you'll see, well, electrical insulation, that's one of them. And then it says arcing effects right here. Now, of course, there's other things here to be considered, right? So, but at the end of the day, this question only had 2 components in it. So the answer to this one's obviously A and B. So the secret to dissecting this question was that you have to look at it and know that it is a general requirement, an installation requirement. Okay, somebody's going to be judging this equipment. So that's a general requirement. We're not talking specifically about any equipment. We're not talking about any wiring method. It was a general statement, and you're going to get a lot of 110. It's like working clearance. Working clearance on equipment, that's going to fall under 110 as well. That's going to be 110.26, those type of things. Trust me, as you go through our program, you'll get more familiar with that. The index, the reason we're not using the index here is because this lesson, we're trying to interact with you and kind of let you look at a question, try to dissect it based on your knowledge. The index is going to be a great resource for you, but look, don't use it as a crutch. It's not the holy grail. Some of this stuff you'll commit to memory. And that's the beautiful thing about our programs is that in our program, you'll learn some of these things so that you won't have to go look it up in the code. It'll just come to you right as you're taking an exam. Whether you're in our black and plus or you're in our basic and enhanced, it's the same material, it's just different delivery styles. You have to read it. And I'm a big believer, you have to read it to retain it. You can watch videos all day long. They're great as a supplement, but you have to read it to absorb it. I need you to go from your course into the code book, back to the course, back and forth, slowly over time. Don't get frustrated. You'll get it. It'll all work out and you'll see how this whole thing works. All right, so we're going to say A and B. And there's our code reference. All right, next question. Connections of conductors to terminals by means of wire binding screws with upturned lugs shall be permitted for blank AWG or smaller conductors. Okay, so you're thinking, okay, well, what does this look like? Well, this very much looks like terminations. And if you're savvy enough to know that you have temperature and termination limitations, all of those are in 110. It sounds very much like a installation, a general requirement, right? We didn't ask about any wiring method. We didn't ask about anything else. These are type questions, and that is the purpose of today's lesson, is to look at questions that you don't think about throughout the code, but these are installation. These are general questions that you're probably going to see in 110. So what specific section deals with terminals and terminal limitations? You guessed it, 110.14. That's the one that deals with it. But let's go look at it in the code and we'll break it down. Now, on this one, you could have looked in your index under terminations. You could have looked under conductors, all those type of things. But what we're doing today is not making the index your crutch. We want to get used in examining some of these questions because our program is designed to help you do this by teaching you the stuff that is liable to be on an exam, but then it also locks it in your brain for later when you're out in the field. Okay, so let's kind of go to the NEC and we're going to go to 110.14. And I'll tell you what it's talking about. Again, 110.14, as you see here, that's electrical connections. And that's what we're talking about. These are just things that now that you're watching this video, you're going to lock this in your head. If you've got a question about electrical connections and it's the termination, you're here. Splices, here. Temperature limitations, this is where you get the provisions for 100 amps or less, 60 degree, over 100 amps, 75. You're going to get all of that information here. So in this case, we're worried more about this termination. Okay. And what is the answer here? Well, you remember what we said when you're taking an exam, you're looking for triggers. Okay. You definitely want triggers. So I don't have to spend a lot of time here. I'm looking in here, and what I see right away, there's only one size that's showing up in here, right? And that is right here, 10. Okay. See these upturned lugs or the equivalent shall be permitted for 10 or smaller. You're going to get so used to dissecting and doing this that our program is going to move you in and out, in and out. I don't know of any program that does that. Don't get frustrated, folks, please. There's a method to the madness, and our program is designed for that madness. And some people get frustrated. You just got to be patient and really work through it. Okay, so we're going to go to the question. And obviously, upturned was in the actual code reference. And then the only one that makes sense here is 10. And there's your reference, 110.14a. Okay. We did not need the index. We understand that 110.14 is talking about terminals. It's talking about splices. It's talking about temperature limitations at terminations, all of that. So that's a general requirement. We didn't ask you about RMC, EMT. We didn't ask you about a conductor's insulation. You'll get used to looking at questions. Our course is going to make you better in the field too, because you will learn to understand these things and just make you better. All right, let's do another one. For a panel fed from a 4-wire delta distribution, the high leg shall be what? Okay, well, look at your questions here. It shall be marked orange. Now, a lot of people are going to jump on that right away, right? They're going to say, oh yeah, high legs always got to be orange. Stop. If you're on an exam, take the time. You got about 2 minutes a question that you're going to dedicate to it. Okay. In that first wave, you're going to spend about 1 minute, a little over a minute. Answer it if you know it, move on, and mark it if you don't, and move on. Don't dwell on it. But look, many people are familiar with the orange, but also marked by other effective means. I'm sure you've seen people say that I could put a number on it, or I could label it. It doesn't have to be orange. Now, if you choose the color orange, then guess what? It has to be orange if you're using a color coding system, right? We obviously know that it's no marking required. So if you have multiple options here, then maybe the best answer is A or B, right? But also, what does this look like again, folks? It's an installation question. It's asking you about markings. It's asking you about that. You're not going to be up in chapter 3 or chapter 4 or chapter 5. This is specific. So it's about general installation type questions. Again, the effort to this episode is to really focus on general requirement stuff so that you can kind of get the feel. All right. So in this case right here, let's go to the code and let's see what we're dealing with. All right. Now, I could go to the index and look in my index and probably look for high leg or delta or that type of thing. I could look under panels, panel boards, that type of thing. Most electricians that have ever dealt with three-phase systems that have a delta high leg, then they might know this answer. But I can guarantee you that the first thing in many people's mouth was orange, right? Okay, well, let's go look here. High leg markings. Again, it's 110. It is under general requirements for electrical installations. And what does it say? On a 4-wire delta connected system where the midpoint of one phase winding is grounded, only the conductor or bus bar having the higher phase to ground, that's the 208 to ground, high leg, shall be durably and permanently marked by an outer finish that is orange in color or by other effective means, okay? Other effective means could be black insulated conductors with orange tape. It could be purely an orange extruded insulated single conductor. It may be labeling system, whatever is effectively going to identify that as the high leg, wild leg, bastard leg, red leg, whatever you call it where you're at. an effective means is subjective, and the AHJ could go either way. But the code says that it can be orange in color, or you can make it orange by taking black phases and putting orange tape on it. Okay, but there are many ways that you could identify it. I don't want you to just immediately choose orange, even though that's probably the most common thing that people do, right? So if we think about that, let's go back to the question, and we're going to be A or B, correct? So we're going to check it. Our references, there it is, 110.15. You see what we're doing? These are all general requirements that we're trying to hammer into your head. Let's look at another one here. And I'm sure you probably guessed it. Where do you, what section or what article do you think this is going to be in? Now you get it. Looking at these questions, and this is what our programs do. These practice questions do that as well, trying to lead you through different questions to kind of get you focused in. All right, so it says, unused current transformers associated with potentially energized circuits shall be what? Short-circuited, grounded, guarded, or marked? What do you think? What do you think? How do you find it? Well, let's look at it here. I know this is talking about what? It's an installation. It's a general requirement. It's telling you what has to happen to unused current transformers, okay? So what do you have to do? Okay, well, you can go to your index, and I'll show you. We'll do this for one here. So we don't have the index online because NFPA does not put the index in a link, so you've got to grab your code book. And if you think of here, I'm going to go to the back of the index, and you could go look under certain things, and let's see. I'll go under like you could, and let's see here. We'll go and look under current transformer. Let's just see what it says under, if there's anything under current transformer. And I don't see anything. Okay, so the next one we can look under is energized circuits, maybe. Okay, let's look under energized circuits. And I'm proving a point with this one, so go with me. So let's see here, and let's see if we see anything under energized circuits. All right, so energized, let's see here. I don't see anything under energized circuit or anything like that, right? Hang with me, don't leave me yet. All right, so now I'm saying, okay, what else could it be under? Transformers. All right, so we'll look under transformers. Let's see here. Now, I've already told you this looks like it's just a general requirement. So you can use our bold scanning technique, go to the article that you think it is, and start bold scanning using the answers as well as some of the parts of the question itself. But we're still looking because I want to prove a point here before we end up today's training. Now, let's see here. So I'm going to go to transformer and see what we've got here. So I'm under T. And let's see here, transformers. Okay, and we're going to kind of go down. I'll look down and see if there's anything in here that will remotely get us where we needed to be. And let's see here. Let's see. I'm looking like you should be looking. Okay, don't just sit there waiting for me. If you go look yourself. And I'm looking down here. Guess what, folks? Under transformers, what does it say? If you've been looking it up in the code, you know, here's what it says. It says, unused current transformers short circuiting of, and it gives us 110.23. All right? Index. It's not the holy grail. But sometimes if you take a question, you break it down, you can find the answer. And for all those that say they failed their exam by 1 point, okay, this one might have been your holy grail, okay? So, but we're not going to stop here. He gave us a reference of 110.23, so we're going to go look at it. So here we are, and we're going to go to 110.23. And it says current transformers right here. It says unused current transformers associated with potentially energized circuits shall be short-circuited. How about that? It says it right there, okay? Now, you probably could have gotten here by bold scanning. Speaking of which, let me look real quick into here and see if there is anything under current transformer, because I want to make sure that we look everywhere and just make sure that it wasn't obvious that it would bite us in the nose. And let's see here. Let's see here. I'm looking. You should look too. This is the whole point of bold scanning and also looking things up in the code. So let's see if there's anything under current transformer. And I thought we already looked under this earlier and we didn't see anything. No, we did not. So we just wanted to verify. So that can be tricky because that says current transformer. That's not in the NEC, the index, but transformers is, and it ended up sending us to 110.23, and that's where we got the answer, right? So we're going to do short circuited. And there you go, 110.23. All right, so let's take it back to me and end this thing tonight. All right, guys, I wanted to point out a couple things here. All of these tonight were basically knowledge stuff that you need to look at it and kind of identify the question. This is not just for exam. If you're in the field, I mean, time is money. Being able to understand whether something is a general requirement for an installation versus something that is more specific to like a wiring method or a specific application like transformers in Article 450, or if it's kind of, the question kind of looks general in nature. And if that's what it is and it looks general in nature, then 110 is going to be the logical place to go because that's the general requirements. For example, working space, 110.26, all those type of things are right there in 110. All right? Okay, that was our lesson today. All we were doing is trying to make sure you get a little more familiar with the general requirements. We have other training that's coming. Do me a favor. If you want to get a lot of good training and you're not in our program, but you want the videos, go to Fast Trax Tube. That's FastTraxTube.com. Subscribe and you can get access to our videos. If you want to get a great exam course, learn the NEC, get all these resources, questions, to be able to come to our bi-weekly or bi-monthly Wednesday nights. You want all those resources? Check out this website and do me a favor. If you've caught this video and you stay this long, do me a favor and subscribe. It really helps out the channel and we appreciate being able to send you this content. Till next time, folks, stay safe. God bless.